Today I'm joined by Diederik Meijerink. Diederik, welcome, first of all, and thank you so much for joining.
Thank you. Thank you for having me.
It's a pleasure. And Diederik, I think it's a great person to get us started with the series. He has over 5 years of experience in leading data teams. I can mention, for example, he has done this at Schiphol, at the data lab at the City of Amsterdam, and also at Pathe, the cinemas. So he has more than enough experience to get us started today with the series, and a lot of personal anecdotes, I'm sure, to kind of draw from as well. Today also with me is Christella. She is also part of the ELU team. So should you have any questions about any of the future webinars or the Coursera course, please feel free to reach either Christella or myself. Now, finally, a few logistical items. If you have any questions, we do hope for this to be an interactive session. So Diederik will be sharing some slides and some presentation, but we also do want to hear your voice. So you can drop any questions in either the chat or the Q&A box down below in the menu, or you can also raise a virtual little blue hand in Zoom. You can do this by choosing raise hand in the menu, and you can also choose to unmute yourself at that time to actually speak if you want to use your audio as well. So with that, and without further ado, I would like to pass the virtual microphone to Diederik. Again, thank you so much, and very excited to get us started.
Yes, thank you. Okay, to guide a little bit the story, I made some slides that I would like to share, and based on that, I'll hopefully have nice discussions with you. Start sharing. Slide deck. Yeah. Well, this is, you can all see the screen now?
Yes, perfect.
Perfect, okay. Yeah, I'd like to start with highlighting data science as a concept. So without insulting your intelligence, I'd like to give it my own spin, and also maybe talk about some trends in the field, and also some dirty secrets that are still very much alive, which I hope we'll have discussions about. And then further on, we'll go to see, okay, how do you start building a data science team, and how would that process go? And if you start building, what skill sets would be nice to have, or maybe very important to have in your team in order to be successful. I'd like to start with that. So I made like two separate descriptions about what data science is, in my opinion. There are a lot of descriptions about, because it's a very broad field, of course. But I think applying advanced analytics techniques in order to extract insights from an organizations or companies' data assets is very important. For that, you can use several algorithms or advanced analytics tools or algorithms. And that is very important, but it doesn't really build you a product. So I always like to think about building data products that can make an impact for an organization. For example, a recommendation engine or a forecast engine. That is a product that ingests, transforms, spits out forecasts in an automated way. So an automated, well-engineered data product is, I think, where the most value can be attained in a business. Not to be said that gaining insights from a very difficult data set, or getting more data sets together that have never been combined before is not important. They can also be very valuable. But I think thinking about the fact that you want to build a data product that works from A to Z, that is something that I like to think about it when I talk about data science. And then it also obliges you to look at it, okay, what kind of skill sets do I need in order to build that product and make it work, make it scalable? Because these are also very important concepts. Because if it's only about insights, you could maybe also use a very good analyst or a BI team to extract those insights. And maybe they can use tools that have embedded techniques, advanced analytics techniques, so that they can also do the advanced stuff. But I think if you're talking about data science and insights, then this is about using the open source community and tooling to extract whatever insight needs to be extracted. But I think that's a nice distinction to make. And in the screen you say, okay, you see trends and a dirty secret. I'd like to have a little bit about the trends that I see in data science. Very high over, and there are many. But a couple of trends that could impact the hiring and the building of a data science team, in my opinion, are themes like data governance. So what do you do in order to take care of your data assets to make it a higher quality, to make your data higher quality? And if you start looking at your data asset as a strategic asset, what can you do to give it the most highly attainable data quality that is possible? Really take care of your assets from A to Z, and that also brings me about the data governance part. Privacy, of course, and security. So yeah, when I was working at Pathe, I was asked to build the advanced analytics capability for the company. And very early on in the process, when we started talking about data products, it was about doing a data impact assessment. It was about privacy. It was about how can we do this securely. And back in the days when I started the data innovation lab at Schiphol, a team that was built from scratch. And we thought, okay, we need to build a lot of data products, but it was not really about the privacy was really important, the security, but it was not in the forefront of the discussion. And now that changed. So I think these are trends and also skill sets that you need to have as a data scientist, or at least be very aware of them before you even start building anything. The other part is, I think, very important is explainable AI. You hear a lot about the deep learning frameworks that are black boxes, and you cannot really understand why the algorithm made a certain decision. And that is very worrisome if you talk about self-driving cars or other applications that you might make. So explainable AI is sometimes abbreviated as XAI, is something that I see more and more. I see more and more frameworks being developed around it. Like, I don't know if there are data scientists here now in the webinar, but SHAP is one of the framework in Python that I see is very important. I saw something about the Dayon, which is about best practices, about how to make your model explainable. And a lot of organizations also pop up, like deos.org or AInowinstitute.org, that are all about the discussion about explainable AI. And I think that is a skill set that also data scientists need to have more and more. I think data scientists, when you hire them, they should be able to make a model, but can they also make it reproducible, explainable, and very transparent? And I think those three key concepts are very important. I think if I may add two more nice trends that I think are important, is that we should maybe sometimes also dare to choose a platform or an end-to-end machine learning platform that enables us to put machine learning models into production, into a setting where it can be used in a real environment, much more faster. And I see a lot of end-to-end machine learning platforms coming up, enabling data scientists to maybe code less. It requires a little bit less technical expertise, but you can use those platforms to really benefit from those platforms to put algorithms into a production setting quicker. Also, cloud enables pre-trained models like the Google image recognition. That's big tech companies that already enable you to use object recognition algorithms right from scratch, and it enables you it saves you a lot of trouble to build those products yourself, because that's very difficult. And the last thing I would like to mention is that I see specialization in data science niches. For example, deep learning is of course very important. Also, it's important to recognize that not a lot of companies are using it maybe yet. And natural language processing, NLP, so extracting knowledge and information retrieval from texts is something that I saw, for example, at DAS, which is a company that deals with jurisdiction and helps people with legal issues. So they have a lot of texts available and specialized knowledge. And more specialization niches is something I see in the data science fields more and more. So that gives a lot of possibilities for the data scientists. Now, one of the dirty truths I think about data science, and then I will go on with how to build data science teams, is very provocative from Gartner, which is sort of a think tank about a lot of fields. Among others, data science. They said, okay, 80% of AI projects will remain alchemy, run by wizards whose talent will not scale on the organization. And they say through 2022, only 20% of analytics insights will deliver business outcomes. Now, there's a really high percentage of models that data science are building that are not implemented or not used by the business. And I'm also very guilty. When we started at Schiphol, the first year we built a lot of models, but none of them were actually used or adopted by the business. It was also one of the biggest learnings that I had in my career, that is very difficult to have the business aligned. But this is certainly one of the dirty truths. And another, it's called Algorithmic, which is a marketplace for algorithms. They have a very nice report. I'll maybe link to it later. That's called the State of the Enterprise Machine Learning Survey. And they said machine learning or data science operationalization is really underdeveloped. So there's a big problem there. And it's one of the big challenges in the field, I think. So that's really important to keep in mind when you build data science teams. If you want to start with data science, when do you start with data science? There are like hundreds of reasons why you would do it. I'm just stating a couple. I think one of the drivers that really appeals to me is that you want to be disruptive in your business. So you want to disrupt things that you see in your business that can be done better and that involve data. I had a very nice example, and I saw data scientists that they were looking for at Tradius. It's the fourth line. And they do heavy machinery business. They're in the heavy machinery business, and they're trying to really disrupt that field with data and AI, artificial intelligence. By the way, AI, artificial intelligence, I think is a bit of a buzzword to talk about advanced analytics and machine learning in the first place. But it's used a lot. And it's nice because by building a data science team around them, they try to disrupt a very dusty business, meaning the sales and the the inventory of heavy machinery. They are looking at algorithms to automatically generate features from photos from the heavy machinery so that they can tag them and generate a lot of attributes so that you can know what this machine actually is without maybe describing it in detail, which is nice. And yeah, there are a lot of examples. When I was at Schiphol, we wanted always to be Europe's preferred airport, but we also mentioned that it could be done by doing things smarter, using data and data science. For example, building a predictive model that can be used by the security lane planners to optimize lane planning. And lane planning is something, security lane planning is something that is done manually with a lot of expertise, so no critics there. But it's turned out that algorithms can do it a lot quicker and also potentially smarter, so you can save a lot of money. And if you add that up on a yearly basis, you can really save a lot of money. So you should use data science and the latest data innovations when something can be disrupted, when you think that your data has value. That's a mindset. And if you treat it as such, as a data asset, and you start mining it and taking care of it as if it were really important for your future goals, then yeah, a lot of nice things can happen.
Diederik, if it's okay, I would like to bring in 2 questions from the audience. First of all, at what level of maturity do we need a data scientist in the organization? And when is it a good time to consider not just a data scientist, but a data science team?
Yeah. I'm gonna answer that with this slide actually. So how to start with data science, because that depends a lot on the organization. But let's assume that you want to start with data science and you want to bring in a team eventually, but you should start somewhere. So a good way to start is to recognize and investigate the major impact that can be done. And when I was hired by Pathe, the cinemas, I first did a lot of in-depth interviews with experts in the field that know a lot about the cinemas, how the cinema works, about the cinema industry. And you try to gain as much knowledge as you can, and then make that translation about how can we use data in order to make product optimizations or process optimizations and things like that. And if that's clear, then it's really important to prioritize those and pick the projects that can potentially have the most impact. And that's that's when you start to realize what you want to build. For example, at Pathe, it was about being have a more optimized choice for customers through building a recommendation engine. Now, building that recommendation engine can be done by one data scientist that can pick up the model, build it, and then demo it to the organization in order to gain traction and enthusiasm. As long as the business is aligned, it's very important to do that. And if you demo those products to the organization, and one would wish to see more of those products, then you're in business, because then you start thinking about how can we scale this? How can we make more data products, more recommendation engines? And most of all, such a demo is done in a notebook, which is a sort of a web-based interactive environment that data scientists can use to prove a value or to demo something to the organization. But it's not a data product in itself. It's not an engineered pipeline from, it doesn't really exist. maybe on a notebook or in an environment, but it's too small to have impact. So if that demo goes well and one believes in your product, then you start thinking about, okay, how can we scale what I just said, and start building more products, and what do we need for that specific goal, and maybe we should get a team in. And that's where building data science teams comes in, and then you need to have a good look at the skill sets that you need in order to build those products. Now, one thing I would like to add is that in that stage, I think it's crucial to strategize before building. So have a good strategy. Maybe it's a data strategy, or maybe it's a data science strategy or an AI strategy, whatever you call it, but you need to be thinking about the requirements, the business requirements, what do we need to build, how we're going to prioritize it, and all those questions in a very clear strategy that is aligned to the global company or organization strategy. It should not be a strategy in itself, but it should strategize on how data and data science can help achieve the company's goals quicker, better, in a more optimized way. And then you start building, and I think that's the point where you really start building a team. So there was a lot of introduction, but I think we arrived at the point, okay, now we need a team to scale. And the other, there were two questions.
Yeah, thank you. And the second question is, I think, very much related. So this is when there is actually already some analytics present or some data team present in an organization. In this specific organization, there's already a data analytics team. What do we need to do to transform this team towards data science?
Yeah. Yeah, you see a lot of companies have already some business intelligence capabilities, or a couple of analysts, business analysts inside their organization, sometimes scattered around or sometimes within the umbrella of a central BI team. Now, in order to make the step to data science, of course, you can do two things. You can get somebody on board to help accelerate the team, again, based on use cases that have impact for the organization. Maybe you can hire an external to really accelerate. Or you, of course, create an FTE, an extra place in the team. Maybe, yeah, that's something that you could do within the BI team, but you scale the BI team a little bit more towards advanced analytics by adding a data scientist in that team. And you can also say, okay, I want to go for the long run. And I want to have my BI experts go towards data science by picking up tutorials or picking up some books. It doesn't matter how you do it, but people need to invest in knowledge. You can also do all three at the same time. There's no guidebook for that. And it really depends on the organization and the projects that can that need to be developed. And sometimes I think that happened at Heineken. I know that Heineken really scaled their data science capabilities, and they got in a lot of externals. A lot of impact was made by shifting the existing capabilities more to data science. So everything was at the same time, but they had a lot of use cases to work on. They had big plans and a good strategy. So yeah, there's no guidebook. You can do a lot of things, but shifting, like for Pathe, which is a very non-technical company, to shift the organization around towards advanced analytics is like turning a tanker on at sea. It takes time. It's very time consuming. So if you want to accelerate and you have the budget, get an external in and make sure the knowledge transfer is that's very important. So they should take specific care for that, because otherwise people go in and they go out and build something, but yeah, you don't really know what's happening under the hood, so nobody learned anything. And I think if the budget is there and there's a lot of promising use cases, I would move on all three fields. Get maybe an FTE in, hire somebody for that acceleration, and also take care of the knowledge shift that is necessary in an organization. So invest in knowledge, and it takes time.
Great. Another question that has come up is, who should the data science team report to? Is it a CIO, a CTO, or a CDO?
Yeah, that's a good question. I think it's, well, it fell a little bit out of the box, but that's okay. And I think it depends a lot about how the company has structured and organized data science within the organization. At Schiphol, we started with a central data science team, and we were basically reporting indirectly to the CIO. So we're very attached to IT, which makes sometimes sense because IT is also sort of a non-political party within an organization. What I mean with that is that if you put your data science capabilities or team, I don't know, under the commercial department or under the umbrella of some e-commerce or marketing team, or attach it to that, then you also sort of make a statement that that's very important. And for an e-commerce company, I understand it makes sense, but for Schiphol, it doesn't. Schiphol has also asset management and commercial activities. So placing a data science team very heavily under the wings of one of those business units doesn't really make sense, because you take a political stand, sort of. So in order to remain apolitical but also independent, it makes sense maybe to start in very close collaboration with the IT department and under the wings of CIO. That is a very good stakeholder to have, because in the end, data science is also about building data products using an existing IT infrastructure. So having good friends at IT is extremely valuable. Then again, you can also choose to start otherwise if it makes sense for the company. And I think when data science teams are growing, there are a lot of different ways you can organize your data science capabilities. And I mentioned here a couple. It can be fully centralized. And again, then in the startup phase, that's logical. You can also have initiatives in multiple parts of the business. When Schiphol data science team started to grow, there was one data scientist that was sort of moved to asset management because that required specific skills, and it was it made sense to have somebody also elsewhere in the organization. And we made sure that as long as we reported back to each other, we remained a very close unit. That we continue to share a lot of knowledge and common practices. I think that's very important. That could also work very well. So a lot of possibilities. It's a very broad theme, actually. And it really depends on your organization and culture also.
Thank you so much. No further questions for the moment, so perhaps I'll pass it back and you can continue with the slides.
Yeah. When I talked about aligning the business and get a go for to build data science products, and you have a clear prioritization on what you want to build, then typically for an organization that has not data science capabilities yet, a new phase will arrive, and that's the sort of rapid prototyping phase, and you need to build something and extract value quickly and show that to the business and show, okay, this works. I have a working product. What do you think? And how can we use this in the future? And what do we need to do to really build data products based on this prototype? Now, one of my learnings building data science teams, and one of the failures actually in the first year, as you can maybe mention it like that, is that the alignment of the business is incredibly crucial and very important, because otherwise you are a data science team building very cool products, at least that's what you think, and then nobody uses this or uses your products, or it's not adopted by the business. For example, when we built that security lane forecast model that I just mentioned, it was not adopted by the security department, because they also had their own culture of, okay, we do things the way we do, and why should we use your model, even if you prove me with this demo that it's potentially worth a lot of money. And actually, I'm very convinced that data science teams can build incredible products, but without the business adoption and the business alignment, you're not gonna make it. So that's why I keep hammering on that aspect. When you build data science teams, you also need to make sure that if you can afford it, maybe to add a product owner role that ensures that the backlog is filled with relevant topics and stories fed by the business. I know, for example, that big banks like ABN AMRO and ING have analytics translator roles, which is a specific role that is amazing to have in your team, that sort of fills the gap between the data science team and the business, because they don't always talk the same language. So it's great to have such a role in your team and help the adoption of data products in the business. So a lot of roles are possible. And to finish my story about how to start with data science, then there's always a moment that you have this end demo or this special event, and when you ask for commitment of the business or the board of or a team of managers, whatever. What now? If you want to keep on building this and scale out, we need a team, and for that you need their commitment, and this executive buy-in and the C-level suite buy-in is really important for the continuation of and growing your team, because what you did until now is maybe building a prototype, maybe one data scientist will do it, or together with an engineer. When we were prototyping at Schiphol, we were only 2 people, but yeah, that's not enough if you want to scale out. And, yeah. And if you want to scale out based on the before mentioned strategy, it's really important to attach it to that. Then you can clearly indicate what roles you need for in order to be successful. For example, this strategy might entail that you get your basics right about the data, meaning high quality data. Maybe you need a data manager or data steward to work in your data quality. You need a platform in order to open up the silos and extract all the data on one platform. For that, you definitely need a cloud engineer in the beginning or a data engineer, which are roles that are that I can mention in the next slide. And then, of course, build those data products. Yeah, you need the data scientists. So depending on the business, these are the roles that you will be looking for, and start building it in a way fit for the culture of the organization, be it centrally, hybrid, or decentralized. But yeah, it will all prove itself. It's important to just start, and the organization and the politics will have an influence anyway on the team and how it will be organized later. But start with specific roles. I mentioned here a couple: data scientists that build data products. I'm really gonna describe it as easily as possible, and then maybe you have a data analyst, which is somebody that is very fast at mining potential insights from data and discover hidden gems in the data that can be further developed and passed on to the data science team. Or data analysts can also be in the data science team itself, doesn't really matter. Data engineer roles, if you want to have a platform, I think data engineers are good at building data pipelines, so extracting data, land it on a specific platform, maintain that platform. Can be a cloud-based platform or an on-premise platform, or a hub or data hub, whatever you want to call it. But you need to centralize somewhere your data so that you can get a grip on it and take control over your data assets. And that's where data engineers are really valuable. And then, of course, data management specialists or data stewards, different names for different roles, but they take care that the whole organization around ensuring that your data is at the highest standard and quality standards possible. And then the business liaison is maybe the most undervalued, but I won't. In my experience of the last 5 years, it has proven absolutely critical to have a very, very close relation with your business for which you build the products. Invest a lot of time in stakeholder management, tell the real story about what you're building and get them on board and make them also co-responsible for the end result in order to succeed with the team. So different roles, and I know it's a lot of information. It really depends on your organization and products again, but these are some roles that you could envision if you need them and if you can afford them, of course. Yeah, I already talked about the organizational structures. I also said, okay, these structures evolve over time because however the political winds may blow, that's also very important. If you have, for example, a data science team that built a very cool product, and one I can mention at Schiphol Airport, I was not involved in it, I already left, but it was concerning a system that could identify all the different operations that a turnaround process involves. So a plane docks at a station, at a gate, and a lot of processes are happening. And via camera images, they could use deep learning models to extract, okay, this is the moment that the avio bridge connects to the plane. And then you timestamp it, etc. This is when people are offloading on the plane, or this is when new fresh kerosene is put into the plane, timestamped, blah, blah, blah. So you have a lot of different intelligence that you can generate just by analyzing the images. That was so promising that team was extracted away from the central team and then put under the wings of the CDO. That can also happen. So the CDO, Chief Digital Officer, again, not involved, but yeah, you can also be so successful with a product that it gets so promising that you're dragged apart from the central team. You know, change is constant, and that's what makes it so incredibly nice to work in this field. Yeah, it can evolve very quickly. Lara, are there any questions?
No questions from the audience for the moment, but if I can, I would like to pose one question. So you spoke a bit about the roles as well. I'm not sure, Diederik, how much you have been involved also in the recruitment of your teams. So I was wondering, what are the competencies that you are looking for as you're recruiting team members for your data teams?
Yeah. Well, I mentioned the new trends and the dirty truth of data science still, that not a lot of products are productionized or are put into production or adopted by the business. So I think when we recruit, it's important to take extra special care on these on the skills that help facilitate these challenges. So apart, of course, from the knowledge about machine learning algorithms, coding skills, database knowledge, of course, technical skills. Are you able to perform some Linux commands from the command line? Know your database technologies, know the landscape, know the trends. That's, I think, was already the case. So very important. And yeah, you can assess those skills by doing an assessment or doing an in-depth interview, or ask data scientists to share some work or some code. I always like to ask data scientists if they have some private repository on GitHub, which is a code repository in which you can share your code and collaborate together, and to share some personal projects. So again, that was already the case, but yeah, if you look at the latest developments in the AI or the data science field, so yeah, again, data governance, security, privacy, explainability of algorithms, also brings us to, and the fact that a lot of machine learning algorithms never get implemented. I think that on top of that, I think it's really important to have good soft skills. Communication skills, it sounds like an open door, but can you also help as data scientists get the business aligned as much as possible in order to enhance the chances of adoption? Very important. And maybe but maybe you're going a little bit towards the unicorn, because it's very difficult to have all the skills in one person. But engineering skills, I mean, data engineering is a specialized field, and a lot of data engineers that can do a lot of stuff when talking about implementation of models and building a well orchestrated and robustly engineered data pipeline, so from ingestion to the deployment of a model. But it would be great if data science also have some knowledge about how to scale their models, about how to have some best practices about deployment. So basically a little bit geared towards the data engineering skills. I know these are maybe separate roles for the moment, but maybe they blend and they overlap quite heavily in a moment. And if one of the trends is explainable AI, then I think reproducibility and testing and version controls, the non-sexy part of data science, is maybe also something that needs to be stretched. And I don't see that happening a lot in data science interviews, because it's not very sexy. We'd rather talk about the algorithms and the business impact, which is of course very important. But then again, if you want to have explainable AI, you want to have algorithms that are transparent, you also need to have a very good idea about how to do this. So yeah, it's quite a lot to cover. But yeah, of course, the main skill sets remain, yeah, good coding skills, statistical skills, maybe some software engineering best practices that you can use in order to, yeah, build data products that work.
Thank you so much, Diederik. We have some final questions. I do want to make sure also that you have kind of finalized your presentation that you have prepared. Yeah. So perhaps you can quickly run through it, and then we'll go through the final questions.
Appreciate it. Yeah. Yeah, some personal anecdotes I'd like to share. Maybe you already mentioned them. When you hire a data scientist in your team, I think it's important to have an open mind. There are a lot of descriptions when people are looking for data scientists. They say, okay, I need a computer vision master, PhD, and I need this and I need that. But if you have an open mind and you also envision other sort of skill sets to onboard your team and have an open mind on people that maybe don't have a PhD in computer vision or artificial intelligence. I know this helps, and this is an amazing basis, of course. But yeah, when I was studying back in the days, I know I sound old, but there was not a data science master or study. So more of a self-learning type. In my opinion, that should also be fine. But I think if you, in the interview process, and when you consider data scientists, also look for how curious are they? Do they show real curiosity? Do you have a hacker mindset? Meaning, okay, if problem A cannot be solved with tool C, then I can use another tool. It doesn't really matter how we do it, at least as we get to an end result. And that involves like flexibility, hacker mindset, and a curious approach of life. And that these are really nice things to have that I would argue are really important, and maybe arguably more important than than a very in-depth knowledge about a specific algorithm. Of course, you need to have the knowledge, but yeah, these are sort of soft skills that I would like to mention that are important. And yeah, good hiring process, as I mentioned here, is on the communication skills and the cultural fit of the organization. And sometimes you have very beta-minded introverts, very smart people that maybe might not be a good fit with, for example, Pathe, where I work, which is a cinema with cinema freaks and very good marketeers. It's very open-minded, a lot of parties. I mean, that's not a good fit. You need to also pay attention to that. And yeah, it is a bit of an open door, but building data science teams is not only about building the teams, it's also about the processes, it's about the platform that you might use, about the tech that you want to choose, and it's the combination of a whole culture that needs to fit the organization. And excuse me, just to read this. Yeah. Yeah, so building a data science teams in the beginning is chaotic, and it's like for data scientists, it's like you join a startup. There are no established processes in the beginning. You have to build it yourself from scratch, and that's okay. The structure and the uniformity of processes will come later. Also important to have, but in the beginning it's fine to have a culture of experimentation and let people discover their own strength and grow within the organization, as long as the business impact is proven and you are keeping in mind that the data science products also need to be implemented. Yeah, so sort of quick takeaways that I mentioned that proves very valuable to me to never forget is to align the business. I mentioned it a lot of times. You will also be much more successful if you have the right sponsorship and leadership and C-level support. It sounds like an open door, but it's a lot of work and it takes a lot of cups of coffee to get there. And there are a lot of stakeholders that you want to be in your fan club, sort of say. And it will really help you grow if you have the right support. Because then other people will knock on your doors and can you help us too? And it's crucial for success. And yeah, go for quick impact is more in the beginning. First, if you prioritize your first use cases, pick the right one and make sure that's the one that makes a real impact. Because with that real impact, you build credibility, you build trust, and you can grow even further. And yeah, so successful data science teams, they collaborate again with the business, They synergize with other data-related tasks or skills that you have in an organization. It's important to not to forget that also business intelligence is very important, that the business analyst is valuable. So work with them, and yeah, ensure mixed teams. The diversity in teams is, I think, really important. But that's maybe another topic.
Thank you so much, Diederik. I think it was such a rich conversation that we've had. There are some final questions. So one final question, maybe in the last couple of minutes, is how can I sell the idea of a data science team to my management, which is too traditional at times?
Yeah, that is traditional at times.
When the management team is traditional, how can you sell the need for a data science team?
Yeah, by picking a project that has potential impact, ask for commitment to build a prototype, and go towards a quick demo product that proves that value. Because if you cannot prove it, if you don't really build something, you cannot convince management, in this case a little bit more traditional, that these new approaches could work. So yeah, and if you don't have time to do it yourself, and you don't have budget, then it gets a little bit more complicated because you cannot hire somebody to do it for you. I will not argue that you should do it in your free time, but I think if you really have a good story to tell, you should be able to have a little bit of time to prove your point. And if you do it well, then they hopefully also will be convinced that this is maybe a new way to go. The data science can add value, but yeah, again, you need to be really convincing and build something that works, even small, but based on real data of that company. And that hopefully clears their mind and shifts their perspective a little bit. And then you're open for next discussions, etc. But I think it's important, but can also be challenging. I'm not sure about the insights of the question.
Great, thank you so much. So for the final minutes, I just want to see if my colleague Christella has any final questions. And after that, I think we will be wrapping up.
Yes, I do actually. Thank you. Thanks for the presentation, Diederik. I was wondering, with everything that you have learned and that you shared with us today, if you could go back in time, what would you do differently in your career, or for example, at one of your previous employers?
Yeah, good question. When I would go back in time, I would make sure that I had the right credentials on my CV based on my studies. So I could not study data science, but could I have studied it? I would definitely have gone for it. It was not possible at the time. I think it's a nice base. So, but that's way back in time. That's 20 years. Huh? But if I would go back into time at the Schiphol, for example, time, and we started building the team. Then right from the beginning, I would have made sure that the cross-functional teams were in place right from the beginning, because in the beginning it was a little bit of a data science fest. We were a lab, we were a small team, and we were having a blast because we were testing out new technologies, Hadoop at the time. We built a couple of data products that we thought were really cool. We were a little bit in a bubble. And at that time, 5 years ago, 6 years ago, it was sort of fine. The implementation and deployments were already topics that were important, but not on the forefront of that's really important. But now those times changed, right? So at Pathe, when I came in, it was right about implementation, right about deployment. And it's about not wasting any resources on data science. So it's got a lot tougher. Also meaning that the skill sets that we ask from data scientists are, I think, tougher than 5 years ago, because now all the extra skills that I mentioned are also very important. So that's what I would have done differently. I would have made cross-functional teams right away and not after hacking around for a year. And we will build very nice products, so don't maybe be mistaken, but again, the first year we didn't implement anything. And that's something I would not have done the same. That's my biggest learning. Yeah.
Yeah, I understand. Thanks. Makes sense.
Thank you, Christella, and thank you so much to Diederik as well. We have come to the end of what I think has been a very, very rich hour. And I know for myself that I've done a lot of learning in this session. So thank you again, Diederik. And we hope to see you at any future sessions. Just a quick note, this session has been recorded. It will be shared also with those of you that registered. So you can also watch it back to again catch something that you might have missed.
Thank you, Diederik.
Thanks.
Thank you very much.
Thank you, everyone. Have a great evening.